Hi everyone. Today we're gonna take a look about the second derivative. Here we learn about some theory, geometry, and application. Uh, we already know that the first derivative describes the slope of a function, and the second derivative tells how the slope is changing. So we can say that the first derivative is how something changing fast. The second derivative is how fast the change itself is changing. It's seems like a little bit complicated and not understandable, but I can tell you one real example to that. It's in the physics we have a position, velocity, and the acceleration. So acceleration is the second of derivative of position. And I have also one quick question for you guys. So what does the first derivative represent geometrically? Mm-hmm. Mm-hmm. Got you. Yes, of course, it's the slope of the tangent. So here, we will know some definition and the example of it. So if a function f of x is a differentiable, so and its derivative f of x is also differentiable, then we define the second derivative is as the derivative of f of x in double prime. So here we have a form of it. So let's take a look on a quick example here. So we have here f of x equal to x squared. So x cubed, I mean. So first derivative, as we know, is just we move this 3x squared to downside, and it's gonna be 3x squared. Correct? Yeah. And we are doing the same, we derivate this function one more time, so it's gonna be 3 times 2 and x 2 minus 1, so it's gonna be just a 6 of x. So second derivative of f of x measures the rate of change of the slope. So here's the slope f of a derivative of f is equal to 3x squared, and it increases linearly in x because of double prime of x in x squared. So here we have a limit form. It's some rigor same example. So it's the same as we know, but we in here we are using limit. So our limit h is approach to 0. So here our a general formula for it. So f prime x plus h minus f prime of x over h. So here's our formula where h is approach to 0. So we just substitute into formula here x plus h minus 3x squared is equal to x. We're just doing a second combination, so we in the end we have z, and where x is approach to 0, so we just substitute and we got 6x. So it's a concavity. So it's just a basic trigonometric function, first and the second derivative. You can just take a picture of it. So now we're gonna take a look a little bit on a concavity. So now we use the second derivative to describe the shape of the graph. So if f of x is bigger than 0, the graph is concave up. If f of x is less than 0, the graph is concave down. Like concave up means that the slope are increasing. Concave down means it's like slopes are decreasing. So here we have some graph. So when the concave down, so it's decreasing as you see, and if concave up, it's increasing. If of like f of is constant, so we don't have a concavity here, and like our expression, our double derivative is equal to 0. So we here also have a local min and local max. So first we find the critical points using the first derivative here, and then we classify them using the second derivative. So like at a critical point f f of x equal to 0, if f of x is bigger than 0, so it's local minimum. It's if it's less than 0, so it's local maximum. So interpretation, I can say that like a second derivative tells us whether the graph looks like a bowl or a hill. Like a bowl means like a minimum, a hill it's a maximum. This is how I can draw to you. So it's a bowl, it's a hill. One moment, I have a problem here. So bowl, hill. So here we go. Something like that. And here we have like inflection point. So an inflection point is where the graph changes the concavity. So we have like one important rule here. So like the necessary condition f of x equal to 0. So but this alone is not enough to concavity must change the sign. So like as you can see here. So like f of x equal to x cubed. So first derivative is 3x squared, second derivative is 6x. So here we have like if a second derivative of is less than 0 for x is less than 0, and f of the second derivative of x is bigger than 0 for x of 0, the concavity change at x0. So you can see here, so our concavity is x is 0, so it's an inflection point. So we can see how the graph is changing here. Here we go. It's not changing. So it's just also explanation about some local extreme. So I already told to you, and in the physics we have accelerations, as I mentioned in the beginning of the class. So if x of t is a position, so here are like a general like a formula like as a velocity. So velocity, as I said, is a first derivative, and here we have acceleration. So acceleration, as I said, is a second derivative. So in the second derivative of the position is acceleration. So a of t is bigger than 0, so velocity is increasing. It's the same as mentioned on the local maximum and maximum. So here we have a concavity, so RDS and short inside. So it's just not enough time to explain everything. So I will just skip here. Check it. Is everything good? Oh, okay. So everything is recording. I was just looking at it. So we have here just practical questions. So we have determine the first or second, like a first derivative and the second derivative is easy. Here we have like this, we have like 3x squared, so it's gonna be 6x. Here we have 4x cubed minus 4x. Correct? Yes. 4x cubed minus 4x, so it means 12x cubed minus 4. So, and the other examples you can also solve it at your home. Here also we have some examples. Here's the answers for it. As you see, we solve first one correct. So e of x on like a derivative, it's gonna be same. Ln x, we have here answers to second, here everything. So what I can also say here, we should conclude the what we learned today. So we learned that like a first derivative is some changing. A second derivative it's a change. It's a change of the change. It tells about like a second derivative tells about some like stability, oscillation, acceleration, and convexity. So the second derivative connects geometry, physics, and optimization into like a one idea. So here, thanks for attention. So, and we have here a little game. Here, so I have here. I was checking on the like before the class. So in that game, we should divide on 2 or 3 teams, and it's just a regular like. If you know like a Svaya Igra in Russian with Wasserman and something like that. So we have like a 3 topics here, like let's find this, and we should like it. Firstly, it should go to like the first team, and they like solving it. We giving like a 30 seconds max. So they are giving answer, and we have their answer. If they're correct, we can add this 100. The other team also choosing some questions, so we have like if of f of x and what type of critical points is x of 0, so we have a local minimum. We also have like a minus here, and as you can see, we have like in every question we have in every section we have different questions. So I think it's like end of my lesson. Thanks for your attention. It was really like a understandable topic, I think. Like the second derivative is the same as like a first derivative. If it was like first derivative, I could give you like more information just because we already learned what's like a first derivative. I gave this all information to you right now. So thanks for your attention. Goodbye.